All right, so today we're working on finite element analysis for the trailing arm. I figured this would be the easiest place to run structural analysis on because it's just a simple beam with two connection points and then a force load right in the center. So it seemed like that was a good place to start. So one of the first things that I needed to do is record the critical dimensions for this part, and that includes the weight and the total length and the shock mount. So the length was 72 inches and the shock mount is 36 inches from the pivot. So that dimension ratio makes the force calculation super simple. So I found this simple design diagram here explaining how force loads are calculated on a beam like this. So if you have a total length of the trailing arm and then a shock mount location and then the corner weight, you can calculate the spring load in the center of the part. And the spring load is not equal to the corner weight. It's a ratio. And that ratio is F1 times L1 equals F2 times L2. And what that means is you're canceling out the torque, so you can run static analysis on a part like this. The great thing about statics is all the forces neutralize each other because the part in the simulation is static, meaning it's not moving. So if you have a corner weight of 2,500 pounds and then a spring weight, it will be 5,000 pounds. Then I'm using another calculator here to double check that. So talking about that corner weight, 2,500 pounds is a lot. I don't expect the vehicle to actually be 10,000 pounds, but what I wanted to do was make sure that I was calculating for worst case, which would be fully loaded vehicle with 4 passengers and a fuel tank. So it's a nice round number to start with. And then as time goes on, I'll probably walk that weight back. So I heard from a video once that in the off-road engineering industry, they usually simulate for a 5G load. And that makes sense. I mean, the G-force any higher than that would just break your bones. And it seems like a good standard. It's a reasonable place to start. So that's what I'm going to start with.